Hi all, we are Team VigilLift from Muthoot Institute of Technology and Science. Myself Matthew C. Manoj.
Myself Leon.
Myself George Ranju.
Myself Jordan Ovira.
Our project is an elevator safety system developed using MYOSA mini kit. Elevators are one of the most transportation facilities used in hospitals, shopping malls, apartments, etc. Even though they are used by millions of people, they lack intelligent real-time system for safety monitoring. Problems such as sudden free fall, excessive vibration, and door obstruction can become dangerous if not detected earlier. Existing commercial monitoring methods are expensive and difficult to install. To solve this problem, we have developed VigilLift, which can monitor the safety as well as the future of the lifts.
Now let me give you a project overview. Basically, VigilLift continuously monitors elevator movement and safety conditions using multiple sensors connected to the MYOSA ESP32 development board. The MPU 6050 sensor is used for mainly acceleration and vibration monitoring. It detects sudden movement, abnormal vibration and emergency conditions. The BMP 180 sensor is used for altitude and atmospheric pressure monitoring, which helps in tracking vertical movement inside the elevator. The APDS9960 sensor is used for proximity sensing and obstacle detection, which can help prevent elevator door related accidents. The OLED display is used to show live data and system status, while the buzzer is used to generate emergency alerts during unsafe conditions.
So the hardware components that we have used in the project are MYOSA ESP32 development board, MPU 6050, BMP 180 and APDS 9960 OLED display and the buzzer module. The software is developed using the Arduino IDE and embedded C++ programming, and the communication between the sensors and the ESP32 module is using I2C protocol.
So, who the project is for? This project is designed for residential buildings, hospitals, shopping malls, office complexes and other elevator systems that do not have advanced monitoring system. So, the system can also be extended for industrial safety system and smart building applications.
Now we will demonstrate the working of our product, the VigilLift. The VigilLift incorporates the MYOSA ESP32 motherboard, the sensors and the OLED to together form a system that tells us the current state of the device and shows alerts if any error occurs. Now this data is also being sent to a server where predictive analysis is done to give us the expected maintenance need for the lift.
So before going into the detailed working of the hardware system, let's first look into the VigilLift live monitoring dashboard. The MPU 6050, BMP 180, APDS 9960 sensors continuously collect data and sends it into ESP32. The ESP32 processes the data and updates it into the server dashboard. The dashboard displays important information like acceleration, altitude, temperature, etc. It also generates emergency alerts in real time and creates an IoT-based smart elevator safety system.
So now we'll show you the first feature, sudden stop. So sudden stop works as if the lift is moving and in between that motion, if it observes abrupt stops in between the motion, we'll get an alert saying sudden stop. Now, as you can see, when the lift dropped abruptly, an alert was formed saying sudden fall detected. This alert is not lost. We get this alert, the same alert on our mobile device, on our mail, and you can also observe the live condition of the lift on our PC application. For our second feature, let's consider the worst case scenario where lift is moving up and falls down, losing control. Now in this scenario, our system will generate an alert saying, well, free fall. Now, as you can observe, there was an abrupt fall to the bottom, which triggered our alert, free fall detected. Now, we've also got the alert on our mobile device and on our web application as well. This is our third feature, irregular motion. Now, this is used for the predictive maintenance of lift systems. Now, as the lift is in motion or if it's constant, any irregular motion patterns will be observed and an alert will be formed on our OLED panel. As you can observe, the irregular motion alert was formed. Device. As you can see, we've got the alert on our mobile device and the data on our web application. This is our fourth and final feature, object detection. This is for scenarios where there's a person approaching and it's within 10 centimeters of range. At that time, the alert will be formed. So observe this where my hand is approaching the sensor. And as it reaches 10 centimeters, it says object detected, open door. Now I'll introduce you to the steps required to initialize and operate the device. So first we power on the ESP32 board, the MYOSA board, motherboard, using a USB cable. Then we give it time for the OLED and the sensors to initialize. Then the live readings of the current state of the device are being taken and sent to our server elsewhere, where predictive analysis of it is done.
In conclusion, VigilLift provides a compact, intelligent and affordable elevator safety monitoring solution using IoT and sensor fusion technology. Our project demonstrates how embedded system and smart sensing can improve elevator safety and contribute to a future and smart infrastructure system. Thank you.